Assalamualaikum. I welcome you all to my very first lecture in organic chemistry. So just let me introduce you myself and or my background. So as you can see, I named the class interactive classes. So interactive classes, what I mean that I don't believe in one-way teaching. It has to be interactive. Personally, I like to make sure that students learn whatever I teach. But now this is virtual class, virtual video class. So we will see how we can make it interactive, maybe by question answer in comment, or we'll see. As you can see, I have nothing to do with chemistry. I am an engineer, just chemical engineer. I am teaching chemical engineering. So question is, this organic chemistry comes from where? You can see that when I was preparing for JEE, Joint Entrance Examination, I fell into love with organic chemistry. So that time I mastered organic chemistry and I taught my friends and so on, and so from that time it is still my heart and mind. So this is pure love with chemistry, especially organic chemistry. Okay, so just now, everyone is trying to explore the multimedia, YouTube and so on, just to reach the people. This is just to benefit our students who are preparing for JEE or medical exam, NEET or whatever. So I expect that you have some background. This is for class 12 student. I will not teach the fundamentals, the basics, the nomenclature and so on. So why I start with dehydration of alcohol? Just to give you a test. If you like my way, then maybe I can make, or if I find time, I can make more videos starting from the fundamentals, basic of organic chemistry, and then we can move on. So you can see dehydration of alcohol, is in the mid of the organic chemistry. So dehydration of alcohol is basically elimination type reaction, right? So when we dehydrate, means we are trying to remove water. So let's start with a simple example. Okay, right now I am using, I'm making the video with minimum resources. So we will see this just whiteboard I have. So we will see later how to improve this and make use better resources to make it better. Okay, so what you have here, 1, 2, 3, propyl alcohol. So when we say dehydration of alcohol, we have dehydrating agent, right? So acid, strong acid, it's like H2SO4, H plus we need it. Why we need H plus, we'll see. Concentrated, right? Concentrated, conc. So it will remove water, okay, minus H2O, that is dehydration of alcohol. So when we say minus H2O or elimination reaction, elimination is when a reaction which occurred just because of elimination of a small compound like HCl, H2O and so on. So here when we remove water, we will remove OH minus, OH and H. So this type of elimination reaction is beta elimination reaction, as you might be knowing. Okay, so when we say beta elimination or beta hydrogen, so beta elimination means the hydrogen will be removed from beta carbon. So when we say beta and alpha, how we define it? Okay, so functional group, carbon attached to the functional group is OH here, hydroxyl group is alpha carbon, and then it's beta carbon, and hydrogen attached to beta carbon is beta hydrogen. So if I remove this, okay, so make it just H, and then this is CH, and this H, if I make it like this, so water removal is this OH minus will be removed. OH minus will be removed, so it will take the hydrogen, so OH minus, and then it will take the bonded electron, okay, OH minus, and then here it is H plus. H plus means it will leave the bonded electron, right, this 2 electron, and then this electron will be shifted here, so you got double bond there. So CH3 CH double bond CH2. So this is alkene. So propyl alcohol, normal propyl alcohol will give you propene. Okay, so this is the very basic concept. Now let's move on and see if we apply the same concept. We will add one more carbon. Okay, so CH3 and CH2, and then one more carbon, CH2 OH. So this is butanol, one butanol. Now what happens when we apply H plus? H plus means proton. H plus, we need it just same like H2SO4. H2SO4 will give H plus. So now if we apply this concept and we see, so in that case this OH minus will be removed and this is beta hydrogen, right? So this is beta hydrogen. If this H is here, so if this not this, if we cancel this, then this is H is here, okay. So in that case OH minus will be removed and this H plus will be removed from here. This bond comes here and we should get this CH3 CH2 CH double bond CH2. Now is this a correct answer? So if we just investigate more, we found that this is not the major product. This is only minor product. Minor means if you dehydrate this, maybe you get this amount as 20%, 10% only. So there is something else which is a major product. So what's wrong now? We applied the beta elimination, but no, this is not correct answer. There's something else. So what's wrong with our concept? Look like we need to see the mechanism of reaction. So something is wrong. We need to follow the mechanism and see what's happening. Okay. So now that's why we need to understand, know the mechanism of most of the reaction to make sure we are able to make the correct product. Okay. We are not misled by the just famous concepts that doesn't work always. Okay, beta elimination and so many things we have. So now let's see this. Now we will follow the basic concept step by step. CH3 CH2 CH2. Okay. One, two, three, four. Okay. So OH has double lone pair, right? And H. Now what we need for dehydration, we need H plus. So H plus, which is proton, always looking for lone pair, it will attack here, right? Then let me say, okay, then so it will attack here. Okay, so it will attack here, and then oxygen become positive. There's positive on oxygen. Oxygen has now 3 bond, which is now unstable. So oxygen being electronegative element, it will attract the electron and it will take the bonded electron and it will move. It will leave the compound, this one, as water. Okay, so if this bonded electron is transferred to oxygen, it becomes water, H2O, and we have positive on this carbon. So look like we are approaching to the intermediate of this reaction. So this is the intermediate, and you have, maybe you know that this is carbocation plus what? H2O. So this is the leaving group here. It's leaving. So this is carbocation. Now this is primary carbocation, right? 1 degree carbocation. If you know the stability of carbocation, then you will realize that this is primary carbocation, and carbocation always like to rearrange. When we say primary carbocation, what does it mean? So positive charge is on that carbon which is attached to only one carbon. Okay, so this is primary carbocation. It can rearrange by hydride shift. Now hydride and methyl shift both can occur. Now here we have the possibility of hydride shift. This hydrogen, suppose this is this hydrogen, one hydrogen is here. Okay, so this hydrogen is moved here, that's called hydride shift. So H minus will come here, this positive will go, and then we'll have positive on a carbon which is attached to 2 carbon. So it means it will be secondary carbocation. So secondary carbocation is more stable than primary carbocation. So here you stop. This is the stable intermediate. Why this is more stable? Because of the positive I effect, inductive effect. Methyl group gives electron. Okay, and here also ethyl group, so it will make charge less, so that makes it more stable. So secondary carbocation is more stable than primary carbocation. Tertiary carbocation is more stable than secondary carbocation, and so on. Okay, so now the last step is, this is the positive. Okay, so you can consider it as alpha, as a function group. So this is your alpha carbon. Okay, now we have beta here and here. So from where it will go? The hydrogen will go from where? This is now last step is minus H plus. So many rules we have, but finally the compound which is more stable, it will form. Okay, so it's, always elimination will take place from where less hydrogen is there. So this is 1. Okay, and you will see that you will get more substituted alkene. So CS3 CH double bond CH CS3. This is the major compound, and this CS2 H coming from here will make this the one propene. Okay, this, sorry, 1 butene. So this is 1 butene, and the other one will be 2 butene. Okay, sorry, this is 2 butene, and the minor product will be 1 butene. If we take hydrogen from here, if we take hydrogen from here, we get this as minor product. This is minor. Not major, and this is the major. Okay, so this is happening because of rearrangement. So any reaction that proceeds through carbocation is prone to undergo rearrangement. Okay, so this is very important point. Please note it down. Okay, I will write it here. So, and you can see in many reactions this happens. We will see later. So any reaction that proceed through carbocation is prone to undergo rearrangement. Okay, so this is not only valid for dehydration of alcohol, but for many other reactions in which carbocation is intermediate. Okay, let's see. So please note this one, and let's see more example. Okay, now right away I will come to a good example, and I leave it. I will do this one. Okay, so this example is very good example. H plus will do dehydration. Okay, now so if you want to apply only basic concept, not going through mechanism, you can do a big mistake and you say, okay, beta elimination, OH minus will go, and then this is beta hydrogen, then double bond will come here. Okay, so that will be wrong. If how we can see if we apply the mechanism. Okay, so we apply the mechanism, you can see OH H plus will come here, water will leave. Okay, positive charge coming here. Okay, now positive charge will come here, this water will leave, so positive charge. Okay, let me write it. This is not CH2 so this is now primary carbocation, right? So you can see there is a chance to make hydride shift and become secondary carbocation. So charge will shift from here to here, and then from secondary there is chance to make tertiary by methyl shift. So I am doing number 1 hydride shift. Okay, number 2 methyl shift, and then you will have tertiary carbocation. Okay, this is tertiary carbocation. So hydride shift, hydrogen shifted from here to here, positive. Then again CH3 shift, positive. So it can have like two steps. So primary less stable, secondary more stable, and then again tertiary more stable than secondary. So now the last step is hydrogen removal. Now you can see this is only hydrogen on beta carbon. Okay, so then here you go, this hydrogen will be removed. Tetra, the common name of this compound is very interesting. You consider only this two carbon, okay, this two carbon, so which is just derivative of ethylene, and you remove all hydrogen with methyl. So this is also called tetramethyl 1 2 3 4 tetramethyl ethylene. So this is interesting product, we got it. Okay, so why what was the special in this question? This came in our time, that was JAE 96. Okay, and interestingly this was given and this was given tetramethyl ethylene form, and it was asked to show the mechanism how it will form. Okay, so now I will just give you some example and some questions to solve. Okay, you do by yourself and then we will see. So okay, sorry, just try to find the product of this reaction H plus. Okay, so that's it for today. Let's see, let's meet later. Thank you.